All right, 2.6. Odd, even, neither. We did yesterday. Graphically and algebraically. That will be on your quiz. This next part, it's actually the beginning, it's just a little longer, is the transformations to graphs. You guys are going to be given equations, and you have to identify all the transformations that are inside. Then you're going to be given the words of the transformations, and you have to write the equations. So we're going to go both ways on your web assign, and then tomorrow in class we'll practice a little more. But right here, yes, sir? Huh? Okay. Right here is like your cheat sheet for all of your transformations. Obviously, we chose Ms. Glick's handwriting because it's way better than mine. But we're going to talk about different parts of a function in the equation. I'm going to talk about the inside versus the outside. Guys, when I say the inside, what I mean by that is anything that's like in a parenthesis or underneath a square root, in an absolute value. That is what I'm talking about when I say inside. Transformations that occur inside the square root, inside the absolute value, inside parentheses. That all has to do with the x-axis. And it's generally the opposite of what you would think. And I'll explain that a little more in a second. Your transformations that occur to the y-axis, your vertical stuff, occurs on the outside of the parenthesis, the square root, the absolute value. So there's different, negative signs mean different things where they're placed. You can either reflect over the x-axis in this case or the y-axis. If you notice here, if there's a negative out in front, it reflects over the x-axis. If the negative is inside, what does it reflect over? The y, okay? If you have a number that is being multiplied to your function on the outside, if it's bigger than 1, it's a vertical stretch. If it's between 0 and 1, it's a vertical compression or shrink. If you have something being added or subtracted to the outside, that's your vertical shift up and down. So anything that's on the outside has to do with our vertical. If you're multiplying something on the outside, it's a vertical stretch or compression. And if you're adding something on the outside, whether it's in the front or the back, but generally it's in the back, you're moving it up or down. So then when we talk about horizontal stuff, anything on the inside, underneath the square root, inside parentheses, or inside absolute value, has to do with your x-axis, and it's generally the opposite of what we think. So if I have a negative on the inside, you think it reflects over the x, but it really reflects over the y. If you have a number being multiplied to the inside, if the number is bigger than 1, you think it's a stretch, but it's really a horizontal compression. It's the opposite of what you think. When you have something being added or subtracted, if it's subtracted, you would think it moves left, but it really moves right. And the reason why, just like with remember when we had the equation of a circle, it was like x minus 2. When you took that minus 2 out, it became positive because there's a negative right here. So if I were to plug in positive 3 right there, it appears that it's negative, but it's really not. So anything that's on the inside is going to be the opposite of what we think. So what I'm going to do now is go through each transformation one by one. And then at the end, we're going to just pull it all together, and you guys will see exactly how you're going to have to do this on the quiz. But the first thing we talk about is reflections. It's like a flip, right? You're going to reflect over either the x-axis or the y-axis. Notice in this first equation right here, your negative sign is out in front. If it's out in front, we're reflecting over the x. If your negative sign is inside with the x, it's going to reflect over the y. And the best way to get better at this, guys, is just to practice it. It's not that you're going to be working out a million problems. You just have to keep reminding yourself, negative on the outside, reflect over the x. Negative on the inside, reflect over the y. You're just going to keep looking at that. All right, for the next example, we're talking about moving stuff up and down. Notice, here is your function, f of x, whatever it is, could be x squared, x cubed, whatever. Here's your function. If you are adding or subtracting something outside, could be in the front, could be in the back, that's going to move your function up or down. Plus moves it up, minus moves it down. Okay, that makes sense? This should be a review from last year. Notice where the plus and minus is now. It's on the inside of the function. That means it's going to affect the x-axis, and it's the opposite of what you think. Opposite of what you would think. So if it says plus a number, you're really moving to the left. If it says minus a number, you're really moving to the right. And again, anything on the inside is x-axis, opposite of what we think. When we talk about vertically stretching or shrinking, that's when you multiply something on the outside. It's multiplying in front of the function. So if it's a number greater than 1, it's a vertical stretch. If it's between 0 and 1, it's a vertical shrink. When you guys are telling me your transformations, you can't just write stretch or shrink. You have to tell me if it's vertical or horizontal as well. It's very important. When we talk about our horizontal stretches and shrinks, again, horizontal is going to be in the inside. Look, it's with the x. And it's going to be the opposite. So if you had a whole number, you would think that it's a stretch, but it's really a horizontal compression. If you have a number between 0 and 1, you would think it's a compression, but it's actually a stretch. Some of your teachers might have used the word shrink instead of compression. That's fine. All right, so the way that I'm going to show you guys to do this is I'm going to tell you first thing you should do is isolate your function. Here is my function. My function right here is x squared. Is there anything being added, subtracted, or multiplied to my x inside parentheses or anything? No. This plus 3 is outside. So what does that mean if you have a plus 3 on the outside of your function? Where is it moving it? It's moving it up 3. That's all you have to tell me. By you drawing the arrow or saying the word up, you're telling me that it's vertical, and then you tell me how much. If you want to write vertical shift up 3, that's totally fine, but you don't have to. What is this doing? Down 2. You could write down 2. You could write an arrow down 2, whatever. Just tell me the direction and how many. That's fine. All right, this is, again, we're going to just practice a couple of these. Here is my function. Do you see my function, guys? There's two things happening to each one of these. There's a plus 4 on the inside, and there's a minus 3 on the outside. One of them affects horizontal, and one of them affects vertical. What is the minus 3? Down 3. Good. What is the plus 4 on the inside? Left 4. Good. Anything on the inside has to do with the x, and it's the opposite of what we think. Very good. So again, look at letter B. There's two things happening. I have a minus 2 there and a plus 7 there. What does that minus 2 mean? Right 2. And what does that plus 7 mean? Up 7. Perfect. Anything that's on the outside is exactly what you think it would be. If it looks like a stretch, it's a stretch. If it looks like it goes down, it goes down. Anything on the inside is the opposite of what you would think. Very important to remember. All right, look at the placement here of your negative sign. Here is my function, and here is my function. How are these two different, other than they're different functions? One's a reflection over the x, and one's a reflection over y. Which one is over the x? A is over the x. Why? Because it's not inside. It's on the outside. Very good. A is over the x, and B is over y. Good job. Mm-hmm. All right. Here's my function. Isolate it. There's a difference here. I see a 3 out in front, and I have a 1/3. First of all, is this going to affect things vertically or horizontally? Is it out in front, or is it stuck inside of parentheses, absolute value, square root? It's out in front, right? So is it a vertical or a horizontal? It's a vertical. Good. Both of these are vertical. You can just write a V. Now, a number greater than 1, vertical, is going to do what? Stretch or shrink? Stretch. Good. It's going to pull it up, make it taller, skinnier. It's going to pull it from the top of the y-axis. A vertical shrink or compression is going to smush your graph down. It's going to make it wider. So you can call this a vertical shrink or compression, whichever you want to. Whichever one works best for you. All right? Notice where your multiplication is. It's inside here. Inside. So is that going to affect vertically or horizontally? Horizontally, good. And horizontal is always exactly what we think or the opposite of what we think. Opposite. So I see a whole number of 2. In my mind, I would think that's a stretch, but I know it's really a what? Shrink or compression, good. So this would be a horizontal shrink or compression. I'm writing either word. You can write either word, doesn't matter. And then what would B be? A stretch. It looks like it would be a shrink because it's less than 1, but it's actually a stretch. Because it's inside, it's with the function, so it's the opposite of what you would think. Now we're going to do 5 little examples, and then I'm going to let you guys get started on your web assign because it's a lot, and I know that, and I want you to ask me questions. But I think you should put Miss Glick's little cheat sheet next to each one of your problems so you can keep referring to it and keep looking at it. Another thing I think is a really good thing to do is to highlight the function. Notice here is your function. You guys can then differentiate what's on the inside and what's on the outside. It's easier to see when you kind of bring it into light there. You guys see what I'm talking about? Now, this could be a parentheses with a square root. I mean, a parentheses with a squared, parentheses with a cube. It could be underneath the square root. It could be inside absolute value. When I say inside, it's going to be inside something. Parentheses, absolute value, square root, something like that. But if you look at number 1, there are 3 things happening on the outside. There's a minus sign, there's a 1/3, and there's a -1. This is exactly how you guys can answer this on your quiz. What does a minus sign on the outside mean? It reflects over x. Good. What does a 1/3 on the outside mean? It's a vertical shrink or compression. Now, guys, notice I separated the negative from the 1/3. That does not say negative 1/3. It says there's a negative, which is a reflection, and there's the 1/3, which is the vertical compression shrink. There are 2 different transformations happening there. What does the -1 at the end mean? Down 1. Perfect. All right, now we're going to move to the inside. The inside has to do with horizontal, and it's the opposite of what we think. So it's going to go which way? Left, 7. Perfect. That's exactly how you can answer that. If you guys want to write me a paragraph essay, that's fine, but I just need arrows and letters. All right, look at 2. Start with the outside first. I have a 2 there, and I have a 5 there. What does that 2 out in front being multiplied mean? Good. Vertical stretch. Very good. What does the +5 at the end mean? Perfect. Up 5. How many transformations do you guys see on the inside? How many? I see 3. There's a negative sign. There's a whole number. And there's that -4. What does that negative on the inside mean? It reflects where? Yep, over y. You would think it's over x because it's inside with the x, so it's the opposite, it's over the y. What does that whole number 3 mean? It's a what? You would think it's a stretch because it's bigger, but since it's on the inside, it's a what? It's a shrink. You got to tell me it's a horizontal, it's an H, and it's a shrink or compression. It's always the opposite of what we think it'll do when it's on the inside. So I see -4. So in your mind, you're like, oh, it's going to go left 4. But you know it's really going to go where? Right 4. Good. Those are the ones. That's why you got to take your time. Go through this 100 times. Go through each one of these. Look at your little cheat sheet. Say, okay, left or right, up or down, vertical, horizontal. Really big deal. All right, write down these three. Take a picture, whatever you need to do. All right, if we're identifying all of our transformations, let's first differentiate inside and outside. All right, this is a square root. So I see one thing on the outside. Guys, am I multiplying this by 7 or am I adding 7? You're adding. So how is that going to move my function? Up, how much? Up 7. You can tell me up 7 with an arrow. If it was being multiplied, then it would be a vertical stretch, but it's not. Now everything else is on the inside. Everything else is going to deal with the x. So I have a negative sign there. I have a 2/3, and I have a +1. What does that negative sign mean? It's going to reflect where? Yep, reflect over y. What is that 2/3? What kind? It's a horizontal stretch. Good. It's the opposite of what we think. Because it's inside, so it's the opposite. Like this is left 1, right, instead of right 1. Anything that's on the inside is going to be the opposite. So it appears to be a shrink because it's less than 1, but it's actually the opposite. And then since we have +1 on the inside, we're going to move to the left 1. Now, when I say inside, this is what I mean by inside. We're inside an absolute value. So anything on the outside has to do with our vertical stuff. It's exactly how it appears to be. Anything on the inside is the stuff that's a little backwards. So I have a minus sign there. It's not a negative 1/3. It's a minus. It's a 1/3, and it's a -11. What does a negative on the outside mean? Reflect over x. Good. Reflect over x. What does a 1/3 multiply on the outside mean? A vertical shrink or compression. Good. Very good. And then I have a -11 at the end. What does that mean? Down 11. Perfect. And then I have one thing that's happening on the inside. What is that +4 telling me on the inside? Left 4. Very good. All right, look at number 3. Differentiate, guys. Inside and outside. I see 3 things going on the outside. Do you guys see them? I have a negative. I have a multiply by 7, and I have a -14. What's that negative on the outside mean? Perfect. Reflect over x. What's the 7? Vertical stretch. Good. And what's -14? Down 14. All right, inside's a little trickier. I see 2 things. What is that 4? Yep, horizontal shrink or compression. Good. It appears to be a stretch because it's bigger than 1, but remember, anything on the inside is the opposite of what we think. Good job. And then what is +9 going to tell me? Left 9. Good. You're going to have some more on WebAssign where it gives you the words. It says like a quadratic function, x squared, that's shifted right 3 and down 2. So that means it would be right 3 and down 2. If they say you have a square root function that shifted up 4 and left 5. So a square root function that shifted up 4 and left 5. Something like that. If it's stretched vertically by a factor of 4, the 4 is out in front. If it's compressed horizontally, then that happens on the inside, right? So just read the words, whatever the function is. If it tells you it's a quadratic, that means you have a parenthesis with a squared on it. If it's an absolute value, then the stuff that's happening left and right and the horizontal stuff will be on the inside of the absolute value. And your up, down, vertical compression and shrink will be on the outside.